And you can't see. Think of some other words that you can use for x-intercepts. You guys know of any? Remember any from Algebra 2? The other class did. Zeros is one. Anytime you're asked to find zeros, it means find the x-intercepts. Okay? Or roots. Or interval endpoints. So all different words for that mean the same thing. So anytime you're working a problem and it says find zeros, you're just finding x-intercepts. Find the roots. Find the interval endpoints. All means find the x-intercepts. Okay? So, this is example 3. Does x equals -2 solve the given polynomial equation. And the polynomial equation is 2x to the 5th minus 21x to the 4th minus 93x squared equal 12 minus 56x minus 68x cubed. So does x equal -2 solve this polynomial? So how can we figure that out? Any ideas, gentlemen?
-2.5 would solve that.
So what math did you do?
You just plug 2 in for x.
Plug -2 in for x.
Same thing.
So what's the easiest way to plug it in?
Plug it in.
Use your grapher though, right? Or use your calculator. So type in your calculator 2 times -2 to the 5th. So grab your graphing calculator app and type this in and tell me what you get. So all I'm doing right now is the left-hand side, okay? And you're going to want to write that in your notes too, so take the time to do that. So the next one we got 12 minus 56 times -2 minus 68 times -2 cubed. So type that in.
I know it was right.
So
No, really right.
So did you get the same thing?
No.
Did you get the same thing on both of these?
No.
They're opposites?
No, they're not. Almost. Pretty close.
Well, what'd you get?
768. Positive 772.
Okay, so in other words, they did not come out the same. So if they did not come out the same, is the answer no or yes?
No.
No, because if they do come out the same, then yes, that number would be a solution. So the answer is no. It's simply a yes or no question, but you got to plug it in to
Which
find
we
the answer.
answered 10 minutes ago.
Right. So you can always guess.
Well, it's easy
Okay.
to know. I mean, look at what you got up there compared to what you don't have.
Okay, so you can just look at this and tell that that's going to
Honestly,
be
it's going to be more than the other side.
really because it came out less,
Oh. Well,
right? Quite a bit less. All
I
right.
told you the numbers backwards.
All right. So
668 was supposed to be on bottom.
okay.
Seriously,
He's lying.
Okay. Example 4.
Compulsive lying.
All right. Example 4. Solve
You probably got asked again.
solve the polynomial.
Okay. Why do we have to write
And
that?
here's
Why
the
don't you just-
polynomial.
X. What happened to stuff we were doing yesterday? This is like.
No, we'll get there.
Well, why would
Okay.
you go backwards? Mike?
It's just they have several types of questions on this lesson.
Because the other one,
So-
all you literally had to do was just plug it in, which is the easiest thing ever.
You had to graph.
Graph it.
Yeah, you can't use the grapher to graph it. You have to graph it like we did yesterday. Yeah, we did stuff off of there. Okay, so, all right, let's solve this polynomial. How can I solve that? How many answers should it have?
Factor.
3, because there's a third power. Factor it, so I could common factor first, common factor an x out. So now I have that. So how can I factor this trinomial?
Let's see. X minus 7x minus 6.
Minus 7, minus 6. Yep, that works. Okay, so now we need to solve it. What would make each of those turn out to be a 0?
7 and 6.
And also, remember, don't forget about this x out front, because I should have 3 answers. So 0, 7, and 6. And those are 3 answers. Okay? Everybody okay with that?
Just us.
All right, so, example 5. Let's say we have one that looks like this. X squared times x plus 7 times x minus 6 is greater than 0. So they want us to solve an inequality this time. X squared times x plus 7 times x minus 6 is greater than 0. So to solve that inequality, so yesterday we had f of x equals this instead of an inequality on the end, right? So there is an algebraic way to solve this. It's kind of a pain and yucky. So we're going to do what we did yesterday, and we're going to graph this polynomial right here. And anytime you see a greater than 0, that simply means where is it above the axis, above the x-axis, okay? So we want to take a look at the graph of this function, f of x equals x squared times x plus 7 times x minus 6. Okay? F of x is equal to x squared times x plus 7. We're going to look at, so we want to graph that just like we did yesterday. So how did we graph that yesterday?
The zeros are going to be 0, negative 7, and 6.
Okay, so those are my x-intercepts, right? So if I draw a graph and I put x-intercepts on 0, negative 7, and positive 6. So there's my intercepts. Are any of them bouncers?
No.
Do I have any even-numbered powers in here? Doesn't this one?
But that's
Yeah, but it's still the 0. That's this one right here, right? So that one's a bouncer. Okay, so it is going to bounce there, so we'll put a B for bouncer. I don't have any really high powers that cause them to flatten out or anything like that. How's it going to enter and leave the graph? I need a leading term. How can I find my leading term?
it's going to be a... Well, we don't know.
How can I find my leading term?
It's going to be a...
Right, but remember how you find the leading term? You multiply the x's together. So you take x squared times x times x. Remember that from yesterday? You multiply the x's together. So if you multiply your x's together, you get x to the what power?
Fifth,
Nope.
fourth.
X squared times x will be x to the 4th.
I thought that was
So if I have
It
an...
doesn't matter what it is, does it?
yeah.
Yeah, because it helps you figure out the end behavior of the graph.
It's going to be a happy face,
Yeah, happy face,
both sides.
parabola, right? So it's going to enter like this and leave like this, right? Okay, so if I... Okay, so
Would be like a W.
The only place it's going to be above it is
through it,
from negative 7 to infinity,
bounce.
from 6 to infinity.
Okay, so I want to know where it's greater than 0, and greater than 0 means above the x-axis. So I'm going to shade in a different color where it is above the x-axis. Okay, so there and there.
Oh my god. Phased up.
Okay? So where is it above the axis? Well, if you're looking at this in terms of the x-axis, so from negative infinity to this number, it's above the x-axis, right?
Are you going to put in -7?
Negative infinity to negative 7. Do I include the negative 7?
Yeah.
Actually, I do not, because there is no equal to sign right here. Okay? There is, it just says greater than, it does not say equal to, so I use a parentheses. Okay? And I union that with what?
2 to 6 to infinity.
Positive 6 to infinity, and that's your answer. That's where it's above the x-axis.
So
Okay.
much more calmer in here without yelling.
Does that make sense? All right, now what if I would have changed this problem? Let's say I change the problem and make it x squared times x plus 7 times x minus 6 is greater than or equal to 0.
Then you bracket it. You can bracket
Okay, close. But the fact that it's a greater than or equal to means anywhere that you are above or on. So this one means
Be at the 0,
above. This one means above or on.
so you'd have 3.
Okay, so you got to remember that when I say above or on, now I'm including this point, I'm including this point,
Triple union.
and I'm including this right here. But that's just a dot. So when I do that one, it's a little more tricky. I'm going to have
Both sides, 0 and 0.
negative infinity to negative 7. You are right, I'm going to bracket it. But I'm going to union that with
Bracket
the number 0. And you've got to use set brackets for that. Anytime you have just one number, use set brackets. And then you union that with 6 to infinity bracket around the 6. So the bracket means you're including the number, but anytime you have a number by itself, you have to use the set brackets. Okay? So I have all of this region, include just the number 0, and then this interval here. Okay? Does that make sense?
Yeah.
So that's the answer if it's a greater than. This is the answer if it's a greater than or equal to. Does that make sense?
Yes.
Okay, let's do another one. Let's say you have,
Is this supposed to snow now?
so x minus 4 times x plus 2 times 3 minus x is greater than or equal to 0. So if it's greater than or equal to, once again, that means I want to know where is it above the x-axis or on. So it's above or on.
So you're gonna
Okay.
have 4 adding an x. Negative 2. 3.
Negative 2, positive 3, and positive 4.
Yes.
Do I have any bouncers?
You.
Will not.
Nope, no even powers. What's my leading term?
It is a 1. No,
That's
it's
the coefficient, the
yeah.
leading coefficient, but what's the leading term? X times x times
3.
negative x. X times negative x.
Oh, so just 2.
So what is x times negative x?
Negative 3.
Nope.
How's it not?
Negative 1.
Okay, I want to know what the leading term is, not the leading coefficient.
Oh.
What's the whole term with the x's? What do I get if I take x times negative x? What's x times x?
2x.
No, that's x plus x. What's x times x?
X squared.
X squared, okay? Now what's x times negative x?
Negative x cubed.
Negative x cubed, right? So that's the leading term. Your leading coefficient, what's the leading coefficient?
Negative x.
Nope. A coefficient's just a number, not an x. What's the number in front of the x cubed? Negative 1.
I said negative 1.
I didn't hear you say negative 1. I heard you say 1. Okay? I heard you say negative x.
Shit, on my lips.
Okay? What's the degree?
3.
3. Degree is 3. Leading coefficient's negative 1. And leading term is negative x cubed. So the leading term will tell you how this thing will enter and leave the graph. How's it going to enter and leave the graph?
I wrote 7.
How? Say it again.
It's gonna
When downhill
Huh?
line.
yeah.
Downhill line, because it's a negative with a odd power. So it's going to enter and leave like this, right? So I got to enter, come down here, go through this, turn around, go through this. Now, I can also find the y-intercept. However, I don't really need the y-intercept just to figure out where it's above the axis, okay? So I'm going to come in, go through this dot. I'm going to turn around somewhere, go through this dot, turn around somewhere, and come back down and out this way. Right?
Basically, yep.
So I want to know where is it?
Negative infinity to negative 2. Unite that with 3 to 4.
Okay, and I want to include, because I have the equal to symbol, right? So negative infinity, you said to -2 with a bracket, because I want to include the -2, unioned with 3 to 4.
Bracket.
Yep.
Both of those.
Does that make sense?
Yeah.
Now, if I said, where is it below the axis, then you would have done the blue regions, okay? Everybody okay with that? Okay, one more, and we're done. All right, let's say you have 4x squared is greater than 11x plus 3. So I want to solve that inequality. I want to know all the values for x that will make that true. So obviously it's a parabola, right? Okay, move everything to one side. And you always want to move the polynomial to the left side because you want to know where the polynomial is greater than, oh, yep, negative.
-3 also.
-3, greater than 0. Don't do it the other way around. Don't put the 0 over here, okay? Because your answer will end up backwards if you do, okay? Polynomial first, then the inequality. All right, so my leading term is a 4x squared, which means I have a happy face parabola, right? But I don't know where it crosses the x-axis at, so let's factor this so that I can find the x-intercepts. Factor it. So you might need a box to factor that, right? So I've got a 4x squared, a -3, multiply it together, and you get,
12x squared.
okay, so I need something that multiplies together to give me this, but adds to give me 11. Multiplies to give me -12, adds to give me -11.
Negative 12 and 1.
-12 and 1. So -12x and 1x. All right, what do these two have in common that I can pull out?
X.
And x, okay? And x times, what, 4x?
Yep. Oh, shoot.
-12 and what? Ooh, -12, I need a 4 out here, don't I?
Yeah.
All right,
Jeez.
so that would be a x and then a
-3.
3, which means I need a 1 down here.
Yeah.
So that means I factor to 4x plus 1 and x minus 3.
Yeah. Oh my god.
Okay,
3 and 1/4.
so what are my x-intercepts?
-1/4 and 3.
Okay, now on a problem like this, they're going to call these interval endpoints. So if you just remember the interval endpoints are the same thing as x-intercepts, you'll be good. They'll say step 1 will be find the interval endpoints. So if you find those, you're going to have interval endpoints at x equals -1/4 and at x equals 3. Okay, so I've got a happy face parabola that crosses the x-axis at 3 and -1/4. So if I draw a happy face parabola through there, my graph is going to look like this, right? Draw a happy face parabola through those 2 points.
Yeah.
Okay, so we want to know where's this thing above. So greater than. So it's greater than here and here.
So is that one going to ask us above?
No, I just happened to pick 3 examples where that way. You want to do this one as a less than?
No.
Let's just change it to a less than.
Make it easier.
If you change it to a less than,
So
that means where's it below?
-1/4 from 3.
So it's below from here to here. So
Brackets.
no brackets. Why no brackets?
Brackets. No
Why?
equal sign.
Because I have no equal sign, right? So it just goes from -1/4 all the way to +3, parentheses around both.
And there's your answer.
And there's your answer. Does that make sense?
Yeah.
Go find 3 really, really hard problems. That way when Screw comes back, we can show him. Like, this is what you meant.